Okay, the next example would go to case 3 for the Frobenius method. The problem statement is asking us to find the solution of this differential equation around the x0 is equal to 0. So in that case, we got to find whether x equal to 0 is the ordinary or singular point by finding px and qx. And from doing that, we know that from px, if we plug the number of x equal to 0 there, px is non-analytical function. So that means x equal to 0 is a singular point. And then now we know it's a singular point, then we got to define whether it's a regular or irregular. So we can find the solution only for the regular singular point. So from that, we got to find the function of x, px, and x squared qx. And from doing that, we know that if we plug x equal to 0 for these two functions, it's still making these two functions to be an analytical function. So that means x equal to 0 is a regular singular point. In that case, we can assume the solution of this differential equation in this form, and then we plug x0 is equal to 0, so we would get y is equal to summation of an x to the power of n plus r, where n starting from 0 to infinity. From that, we can use the integral equation to find the value of r, but in that case, we have to find px and qx. From that, we would get p0 is equal to 3 and q0 is equal to 0, and then you just plug the value of p0 and q0 into this star equation. From that, you can find two values of r, which is r equal to 0 and r equal to minus 2. Which one is r1? R equal to 0 and r equal to minus 2. Which one is r1? 0. R1 is always be the one which is the greater number. So 0 and minus 2, which one is bigger number? 0, right? So R1 is 0 and R2 is minus 2. So the difference between R1 and R2 is equal to 2. 2 is a positive integer. So in that case, let's go to case 3. For case 3, we know that the solution of case 3, y1 is equal to an times x to the power of n plus r1, and y2 is equal to z times y11 x minus x0 plus summation of en x minus x0 to the power of n plus r2. But this one is starting from 0 to infinity, okay? But we know that our x0 is equal to 0, so we know that now that our y1 and y2 would go to this form and that form. Now, we are going to start again by assuming that y is equal to summation of n starting from 0 to infinity of an times x to the power n plus r. And then we do the first and second derivative of y, and then we plug the function of y, the first derivative of y, and the second derivative of y into our differential equation. By doing that, we would get this equation, and then we have x there. We combine this x with the x to the power of n plus r minus 2. So we put x up here, it's become plus 1 there. So you would get x to the power n plus r minus 1, which is this one. Now this 3, okay, so I just put it there. And we have x here, x combining with x to the power n plus r becomes x to the power of n plus r plus 1. These three terms cannot be combining together, but these two terms you can, because we have the same power of x and n starting from the same point. So we put these two terms together and have that term. But the thing is that we want to put all three terms together. So in that case, we have to do the shift of the index. So in this case, are we going to shift this one to become this one? n plus r minus 1 become n plus r minus plus 1, or we want to shift n plus r plus 1 to n plus r minus 1. We are going to shift this one to become n plus r minus 1. Then we are going to replace n with n minus 2. From doing that, now this term I'm going to put n with n minus 2, an become an minus 2, and n here is become n minus 2. So if we put n here become n minus 2, we could get n plus r minus 1, which is the same as this one. Right? Then n minus 2 equal to 0, so n is equal to 2. Now, this term and this term has the same, the power of x, but we cannot combine it together yet because we have n starting from 0 here and n starting from 2 there, so you cannot combine them together. So we can put the number of n equal to 0 and n equal to 1 with this equation, with this function, and then put the rest as a summation by starting from n equal to 2. By doing that, I have these two terms. If it has one term, I said that the coefficient here in front of the term of x would be integral equation. But if it has two terms, which one would become your integral equation? They're saying that the one which has the small power of x, the term which has the small power of x, which is this one, would go to the integral equation. So this is your integral equation. If you find the value, you would get the same as we using the formula from the beginning. Okay. So here, see, we got the same r as we did before as we used the formula. So like I said, you don't need to use the formula because no matter what, you will pass this process. But in some cases, for example, this one, because you have two terms there, sometimes you might forget which one that you are going to pick. If you pick this one, it's wrong. Okay, so that's why they give you the formula of integral equation in order to make sure that you would find the correct values of r. Now, the terms here giving us the recurrence relation. Okay, so if you set the term inside the parenthesis here equal to 0, where n is equal or greater than 2, this is our recurrence relation. So we would get the relationship between an and an minus 2. From that, if you put r, they said that you got to put r equal to 0 first, right? You got to put r1 first. You put r1 equal to 0 there, you would get the relationship like this. a1 is equal to an minus 2 divided by n times n plus 2. And then what do we do next? Just that we press the number of n equal to 2, 3, 4, 5 to see the sequence of a. And then we would get, if we put n is equal to 2, we got a0 divided by 2 times 4. If we put the number of 3 there, we got a1 is divided by 3 times 5. Right, the value of a1. Okay. Before we go in depth, this term, what this term gives to us? This term gives to us that you know that the value of r is not, the term inside the parenthesis is not equal to 0, right? This one we're using the coefficient, the comparing of the coefficients of x to the power of r. So x to the power of r is not equal to 0, so a1 times r squared plus 4r plus 3 should be equal to 0. But the number of r is never, like the term inside the parenthesis is not equal to 0, right? Because you know the value of r is equal to 0 and minus 2. So it's not go to 0, so the only one condition that can make this term equal to 0 is a1 is equal to 0. Okay? So from that, we know that a3 is related to a1. But a1 is equal to 0, makes a3 is equal to 0. And then a5 related to a3, so any a which has the odd number would go to 0. But any n which is an even number would relate to a0. Right? Now, a4 is related to a2, a2 relates to a0. So we still can find the value of a which is an even number. But a with the odd number is go to 0. Now, our y1 is equal to an x to the power n, because r1 is equal to 0, right? So, we put n equal to 0 to 1 to 2 to 3 to 4 to 5. So, we would get a0 plus a2 x to the power 2 plus a4 x to the power 4, because x to the a1, a3, a5, a7, a9, a11, any odd number would go to 0. But any even number always be a function of a0. So we just put it right there.